Hello, friends. So I'm going to try and make a quick video and explain to you how to calculate acceleration. First, let's grab a marker. That always helps when writing on the board. So acceleration is a measure of how the speed or velocity of an object changes with respect to time. So we're looking at the rate at which rate changes. Because remember, speed and velocity are just rates. So now we're just looking at the rate at which rate changes. So remember, velocity is equal to distance over time. And we measure distance in, that's right, meters, good. We measure distance in meters and time in, excellent, seconds, of course. Of course you know these things. It's the joy of being brilliant, right? You just remember all this great stuff we've already been doing. Excellent. So then we get our unit for velocity is meters per second. But now we're going to look at acceleration, which we use a little a for that, lowercase, little a. Is for that, we're going to look at meters per second. So like how much this is changing every second. So we write our unit as a meter per second squared. Because it's like multiplying this, all right? I know it looks like division, but if you write it like this, meters per second times 1 over seconds, you get the same thing of meters per second squared. Fair enough? So what we have to figure out is how much velocity is changing over that time. So follow along now. The formula, I had to grab the notes. The formula for calculating acceleration is acceleration, lowercase a, is equal to the change delta v over the change in time, or delta t. Delta, this, can you see this okay? This capital delta is just a big triangle, and all it means is change. So we're just looking at the change, which is also equal to then how it changes. Or we take, get this, and I think this is awesome, the final speed or velocity minus the initial speed or velocity over the final time, or how long it took total, minus the time we started, or the time initial. Now we can easily rearrange this, and this is where it gets confusing. We can easily rearrange this to solve for time or velocity if we know the acceleration in advance. It's just algebraic rearrangement. Now, I know, I say this, it's just algebraic rearrangement. And a lot of people go, math, no. But math is our friend. Especially in science, we're buddies. So we gotta use it. It helps us. It helps us describe things. So we're gonna rearrange this real quick. And we'll use this form. And then we'll just go back and replace it with these ideas. All right? So if I want to solve for time, let's say, I start with my original formula. Always start with the original formula. Always, just always start there. With the original form. Always start with the original formula. Just do it. Right? Delta V over delta T. So I want to have time by itself. So I multiply both sides by delta T. Now, I know this looks confusing. But really, it's just multiplication. I'm just doing it with letters. It's actually easier to do it with letters than numbers. Don't let them fool you. So these cancel. And we get delta V is equal to A times delta T. Right? So now, if we want time by itself, we just divide by the acceleration on both sides. The acceleration cancels. And bada bing, bada boom, we know how to calculate time. We can say delta T, our change in time, is equal to delta V over A. So if we want to know how much time it took, we just take our velocity, our change in velocity, and divide it by the acceleration we're given. Easy peasy. So then we just replace this and say that the change in time, delta T, is equal to the final velocity minus the initial velocity divided by A. If you want to solve for velocity, we just rearrange it the other way. Come down the board with me. Ready? So what do we do first? That's right, we start with our original formula. So we go back to here. We say A acceleration is equal to delta V over delta T. Now, rearrange both sides to solve for V. All I have to do is multiply both sides by delta T. These cancel. And you get delta V is equal to A times delta T. Or the amount our velocity changed is equal to acceleration over this amount of time. Again, simple. It's easy, I promise. You just got to practice. And if you get it wrong the first 10, 15, 3,000 times, so what? Just keep practicing. You'll get it. You'll figure it out. It's not hard. I promise. We can replace this then. Delta V is equal to A times T final minus T initial. Shall we do a little example? Just for fun? Sure. Come back this way. Hang on. Exciting, isn't it? Okay. Let me erase this. Well, no, I think you can get this in here. Yeah? So let's jump to, where'd that example go? Aha. So the first couple ones on this acceleration practice that should be, pardon me, that should be posted with this video. Let's jump to number 3, where it asks you to find the average number 4. A mains car accelerates at an average of 2.6 meters per second squared. So how long will it take for her car to speed up from 2.46 meters per second to 2.68 meters per second? So we have our original formula. Well, here, let's write down what we know. We know that the average acceleration, A, is equal to 2.6 meters per second squared. So far, so good. And we know, it says how long will it take? So we don't know the delta T, the change in time. How long will it take? We don't know. That's what we're going to find out. So we have the change in velocity. We have the initial velocity, VI, which is 24.6 meters per second. And we have the VF, equal to 26.8 meters per second. So now we just go back. go back to our original formula, always. A equals delta V over delta T. We've already solved for that over here, right? And we found that delta T, or the change in time, and that's what we want, is equal to delta V over A. Or in this case, now we can replace it. Remember? And say VF minus VI over A. It's the same thing. Same thing. This just says the change, and this is what the change is. Now we just plug and chug. So we say delta T is equal to the final velocity of 26.8 meters per second minus 24.6 meters per second over 2.6 meters per second squared. See, easy. So then we say delta T, and of course it should look like this on your paper. You might want to do this on, well, you're doing it on the Google Doc. So you might want to write it out, take a picture, put it on Doc. I don't know, whatever works for you. So, hey, let's get a calculator. Always keep one handy, you never know. So we say 26.8 minus 24.6 is equal to 2.2. And we carry our units through, meters per second, because nothing's canceling. And then we divide by 2.6 meters per second squared. Our meters cancel, and one of our seconds cancels. Because you can cancel one, because that's like 2 seconds, right? Because seconds times seconds is second squared. Am I going too fast? Yeah, you're smart. You got this. All right. So we take that and we divide by 2.6. What'd you get? What'd you get? I got 0.84615384 blah, 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 blah seconds. So that's how long it takes Maine's car to accelerate from this initial speed to this next speed. And now this is number 4. Try the other ones. Try it. Get a hold of me. Maybe I'll make another video about the whole thing later. This is really long, so thanks for your patience. I appreciate it. Good luck, and I'll talk to you soon, I hope.